Hi, I already discussed AVL tree rotation like L rotation, RL rotation and LR rotation. Also how can insert element into AVL tree. For searching and insertion running time is theta of log n. Deletion is more difficult than insertion but still running time is theta of log n. Drawback in AVL tree is frequently rotation. We are doing lots of rotation to balance the height, and that is the only drawback. Let's solve some questions based on AVL tree. These questions are from standard textbook. First question, which of the following binary tree are AVL tree? Three tree are given. We need to check which one is AVL tree. Let's check option A. This is a binary search tree. Left child is less than parent, right child is more than parent. Now check the balance factor. For 5, balance factor is 0. Left subtree height is 2, right subtree height is 2, 2 minus 2 is 0. For 3, balance factor is 1, left subtree height is 1 minus 0. For 2, balance factor is 0. For 6, balance factor is minus 1. 0 minus 1. For 8, balance factor is 0. So every node balance factor are either 0, plus 1 or minus 1. So it is a AVL tree. For AVL tree, balance factor should be minus 1, 0, plus 1. It cannot be plus 2 or minus 2. So option A tree is a AVL tree. Next check option B. This is a binary search tree. Every left child is less than parent and right child is greater than parent. Next, we'll check the balance factor. For 5, balance factor is 0. Left subtree height is 3, right subtree height is 3. 3 minus 3 is 0. Then for 4, balance factor is 2. Left subtree height is 2, right subtree no child, so 2 minus 0, it is 2. Then for 2, balance factor is 0, 1 minus 1. For 1, balance factor is 0. For 3, balance factor is 0. Now for 6, balance factor is left side, no subtree, no child. So 0 minus 2, it is minus 2. Then for 8, balance factor is 0. For 7, balance factor is 0. For 9, balance factor is 0. There are two nodes whose balance factor are 2 and minus 2. As balance factor is plus 2 and minus 2, so this is not a AVL tree. Next, we'll check option C. First check this is a binary search tree or not. 1 less than 3, 2 not greater than 3. So right child always should be greater than parent, left child should be less than parent. Here 2 is not greater than parent. Then here this 9 is not greater than 6. So this is not a binary search tree. As it is not a binary search tree, so it is also not a AVL. For AVL, it should be binary search tree and balance factor should be plus 1, 0 and minus 1. Next question, question number 2. For each of the following lists, construct an AVL tree by inserting their elements successively starting with the empty tree. 3 lists are given. We need to create AVL tree. Let's first do option A, 1, 2, 3, 4, 5, 6. So first we'll insert 1. Now balance factor is 0. Next we'll insert 2. 2 is greater than 1, so it will be right child of 1. Insert 2. Now balance factor of 2 will be 0. Balance factor of 1 will be minus 1. Next insert 3. 3 is greater than 2. So 3 will be right child of 2. Now check the balance factor. Balance factor of 3 is 0. Balance factor of 2 is minus 1. Balance factor of 1 is minus 2. We inserted as a right child. So we will do L rotation of 1. As for 1, balance factor is minus 2. So we will do L rotation of 1. When we will do left rotation of 1, this 2 will be parent. So immediate right child of root will be the parent. Now 2 will be parent, 1 will be its left child and 3 will be its right child. Now all balance factor are 0. Next we will insert 4. 4 value is greater than 3, so 4 will be right child of 3. Now balance factor of 4 will be 0, balance factor of 3 will be minus 1, balance factor of 1 will be 0, balance factor of 2 will be minus 1. It's fine. Next we'll insert 5. 5 value is greater than 4, so 5 will be right child of 4. Again we'll check the balance factor. Now balance factor of 5 is 0, balance factor of 4 is minus 1, balance factor of 3 is minus 2. Left subtree height is 0, so 0 minus 2. Next balance factor of 2 is minus 2, left subtree height is 1 minus 3. And balance factor of 1 is 0, no child. We inserted as a right child, so we'll do left rotation. Now there are two nodes having balance factor minus 2. So on which node we should do the left rotation? The node that is nearest to the newly inserted node, means we'll do left rotation of 3. So after L rotation of 3, this 4 will be parent, 3 will be its left child and 5 will be its right child. So we'll do L rotation of 3, 2 will be as usual, 1 will be same, left child of 2. We'll just do this part. Now 4 will be parent, 3 will be its left child, 5 will be its right child. Now again check the balance factor. Balance factor of 3 is 0, 5 is 0, 4 is 0, 1 is 0. For 2 it is minus 1. So 1 minus 2 it is minus 1. It's fine, it is a AVL tree. Next we'll insert 6. 6 is greater than 5, so we'll insert 6 as right child of 5. Now again check the balance factor of every node. So balance factor of 6 is 0, balance factor of 5 is minus 1, balance factor of 4 is minus 1, 1 minus 2, balance factor of 3 is 0, balance factor of 2 is minus 2, left subtree height is 1, right subtree height is 3. So 1 minus 3, it is minus 2 and 1 balance factor is 0. We inserted 6 as right child in right subtree of 2, and for 2 balance factor is minus 2, so we will do L rotation of 2. When we are doing L rotation of 2, its immediate right child, means this 4 will be parent, 2 will be its left child, 5 will be its right child. Now 4 will be parent, 2 will be its left child, 5 will be its right child. So 5 right child will be 6. And what about this 3? This 3 will be right child of 2. Previously 3 was in the right subtree. Now 3 will be in left subtree. So for 2, its left child is 1, right child is 3. Just mark what will be new parent. When we are doing L rotation of 2, L rotation of root, its immediate right child will be new parent. Now again check the balance factor. Balance factor of 1 is 0, 3 is 0, 6 is 0, 2 is 0. For 5 it is minus 1, 0 minus 1. For 4 it is 0, 2 minus 2 0. So it is a AVL tree. Just mark when we are inserting as a right child in right subtree, we are doing L rotation. Next we will do option B, 6, 5, 4, 3, 2, 1. So first we will insert 6, balance factor is 0. Next we will insert 5. 5 is less than 6, so 5 will be left child of 6. Now check balance factor. For 5 it is 0, for 6 it is 1. So 1 minus 0, it will be 1. Next we will insert 4. 4 value is less than 5, so 4 will be left child of 5. Now again check the balance factor. So for 4 balance factor will be 0, for 5 it will be plus 1, for 6 it will be plus 2. We insert the node 4 as left child in left subtree, so we will do right rotation. Right rotation of 6, as for 6 balance factor is plus 2. So R of 6. After R of 6, this 5 will be parent. Immediate left child will be parent. So 5 will be parent, 4 will be its left child and 6 will be its right child. Now balance factor of every nodes are 0. Next we'll insert 3. 3 is less than 4, so 3 will be left child of 4. Now check the balance factor. Balance factor of 3 is 0, 4 is 1, 6 is 0, 5 is plus 1. It is a AVL tree. Next we'll insert node 2. 2 is less than 3, so 2 will be left child of 3. So balance factor of 2 is 0, balance factor of 3 is plus 1, balance factor of 4 is plus 2. Left subtree height is 2, right subtree height is 0. 2 minus 0, it is plus 2. Balance factor of 5 is plus 2. Left subtree height is 3, right subtree height is 1. 3 minus 1 plus 2. Balance factor of 6 is 0. Now we got two nodes having balance factor plus 2 and we inserted as left child in left subtree. So we'll do R rotation of 4 as 4 is the nearest node to 2. We should do rotation on nearest inserted node. So we'll do R rotation of 4. After R rotation of 4, this 5 and 6 will be as usual. We'll just do rotation on this part. Now immediate left child means 3 will be parent, 2 will be its left child and 4 will be its right child. Now check the balance factor. Balance factor of 2 is 0, 4 is 0, 3 is 0, 6 is 0, 5 is plus 1. So this is a AVL tree. Next we'll insert 1. 1 is less than 2. So 1 will be left child of 2. Now check the balance factor. Balance factor of 1 is 0, 2 is plus 1, 3 is plus 1, 4 is 0, 5 is plus 2. Left subtree height is 3, right subtree height is 1. So 3 minus 1 plus 2. For 6 balance factor is 0. We inserted 1 as left child in left subtree, so we'll do R rotation of 5. As for 5, balance factor is plus 2. So R of 5 means these 3 immediate left child will be parent. So after R of 5, 3 will be parent and 5 will be its right child, 2 will be its left child. Next this 1 will be 2 left child. And what about 4 and 6? This 4 previously was in left subtree, now 4 will be in right subtree. 4 will be left child of 5 and 6 will be right child of 5. Now check the balance factor. Balance factor of 1 is 0, 4 is 0, 6 is 0, 5 is 0, 2 is plus 1, 3 is 0. So this is a AVL tree. So when we are inserting as left child in left subtree, we are doing R rotation and in R rotation immediate left child will be parent. Like for 5, 3 will be parent. For 4, this 3 will be parent. For 6, 5 will be parent. So immediate left child will be new parent. Next we'll do option C, 3, 6, 5, 1, 2, 4. First we'll insert 3, balance factor is 0. Next we'll insert 6. 6 is greater than 3, so 6 will be right child of 3. Now check the balance factor. Balance factor of 6 is 0. Balance factor of 3 will be minus 1. Next we'll insert 5. 5 is greater than 3, less than 6. So 5 will be left child of 6. Let's insert. Now we'll check balance factor. Balance factor of 5 is 0. 6 is plus 1 and 3 is minus 2. Left subtree height is 0. Right subtree height is 2. So 0 minus 2, it is minus 2. Now which rotation will do? We inserted 5 as 3 right subtree left child. So this is the right subtree and here we inserted as left child. So we'll do RL rotation of 3 as for 3 balance factor is minus 2. And in case of RL rotation, root right child, immediate left child will be parent, means 5 will be parent, 3 will be left child and 6 will be its right child. Here all node balance factor are 0. Next we'll insert 1. 1 is less than 3, so 1 will be left child of 3. Now check balance factor. Balance factor of 1 is 0. Balance factor of 6 is 0. Balance factor of 3 is plus 1. Balance factor of 5 is plus 1. It's a AVL tree. Next we'll insert 2. 2 is less than 5, less than 3 and greater than 1. So 2 will be right child of 1. Let's insert. So balance factor of 2 is 0, balance factor of 1 is minus 1, balance factor of 3 is plus 2, left subtree height is 2, right subtree height is 0. Balance factor of 5 is plus 2, left subtree height is 3, right subtree height is 1. So 3 minus 1, it is plus 2. Balance factor of 6 is 0. There are two nodes having balance factor plus 2. So on which node will do the rotation? Nearest node to newly inserted node 2 is 3. So we'll do rotation on 3. Now which rotation will do? So this 2 is inserted as 3 left soft tree right child. Here this 2 is a right child of 3 left soft tree. So we'll do LR rotation of 3. In case of LR rotation, parent, immediate left child, immediate right child will be new parent. Means this 2 will be new parent, 1 will be its left child, 3 will be its right child, and 5, 6 will be as usual. So after LR of 3, 5 will be as usual, 6 will be same. Now this 2 will be new parent for 1 and 3. 3 will be right child and 1 will be left child. Next we'll insert node 4. After insertion, let's check the balance factor. Balance factor 4 is 0, 3 is minus 1, 1 is 0, 2 is minus 1. For 6 it is 0, for 5 it is plus 2. Now which rotation will do? This 4 is inserted in left soft tree right child. So we'll do LR rotation of 5 as 5 our balance factor plus 2. So LR rotation of 5. After LR rotation, 5 immediate left child is 2, 2 immediate right child is 3. So this 3 will be new parent and 2 will be its left child, 5 will be its right child. So now 3 will be parent, 2 will be left child and 5 will be its right child. Again 2 left child will be 1. And this 4 previously was in left soft tree. Now this 4 will be in right soft tree. 4 will be left child of 5. 6 will be right child of 5. Now check the balance factor. Balance factor of 1 is 0, 4 is 0, 6 is 0, 2 is plus 1, 5 is 0, 3 is 0. This is a AVL tree. So when we are inserting as a right child in right subtree, we will do L rotation. When we are inserting as left child in left subtree, we will do R rotation. When we are inserting as left child in right subtree, we will do RL rotation. When we are inserting as right child in left subtree, we will do LR rotation. In case of single rotation, we are doing opposite. In case of double rotation, in which sequence we are inserting, in the same sequence we will do the rotation. Root, right child, left child. So RL rotation. Also mark what will be parent. In case of L rotation, immediate right child will be parent. In case of R rotation, immediate left child will be parent. And in case of RL rotation, immediate right left child will be parent. In case of LR rotation, immediate left right child will be parent. With this, I am finishing AVL tree. In next lecture, I will discuss 2-3 tree. If this lecture is helpful for you, please like and subscribe. Thank you.